Hello and welcome to this video tutorial. I'm going to redo what we did in class last Friday, the park accessibility analysis again, and that should help you to be able to reproduce it at home and also guide you when you are doing the homework, which was the school's accessibility analysis. So here, this is the original map which came with the link that I sent in through Blackboard. So you can see they did the analysis and they have areas that are walkable to the parks, and then the rings show the further you go away, the more difficult or underserved the parks are to those communities. And we wanted to reproduce this on our own. So we're going to go ahead and work on that. So let me bring this map. So that from the data I've given you, I gave you all the things that you need. This is the boundary. So let's go ahead and add also the parcels, the parks. We need the roads, and those are the three things that we will need for now. So let's add those layers to the map. We can check off the parcels. We don't need the parcels right now. But the parks, we can change the parks symbol. Let's call it, let's say tree. Let's find a symbol. You don't want a 3D trees. Let's find something. So those are our parks, and then you can see our roads. All right. Now, when we say walkability, we all know that you can't walk on the freeways. So one of the things that we have to do from the set go is to take out all the freeway streets, because there are no sidewalks next to freeways, and therefore you cannot walk on the freeways to get to a park. So we want to take those away. So how we will do that is go back to your data that you were given. So here, let me connect it back to make a folder connection to the database that I gave you. Let's go here. Go to my drive, find the drive where it is, and projects. Just go over here, projects. Let me find the drive. So here is where all my school stuff are located, and 15. Come here, missing here. So this is where the data that I gave you on my machine at home, this is where it's located. So you should find yours, and the data that you have, this is where the data is. So the first thing I want us to do is, let's go ahead and create a toolbox in here. So right click on the database, go to new, and then create a toolbox, and then you can call it parks. All right, so that's where we are going to and then we can right click on the toolbox and say new, and we want to create a new model. So our model is going to be residing in that. So we can go to model properties as we've done. Then here we can call it park access, and then here we can say the label, we can call it park accessibility. And then we'll go to the environment as we've done, and then define a couple of things. So for instance, the processing extent, we want the processing extent to be the same as the city limit. So we'll go ahead and set that ahead of time. So click on that. It will give you your environment. Bring this guy down here. We want it to be to the city limit. All right. And then the next one we are interested in is a raster analysis. So for the raster analysis, we are saying that this is where we define the cell size and then the max. So here also we want to go over here, the cell size, we wanted a cell size of 30. So we want the cell size to be 30, and then also we want to max, so every raster will be chopped down to the outline of the city. So hit on OK on that. and then the workspace. So the workspace, we want all our workspace to go into the database that we are working on. So click on that and then go on workspace. Your workspace, you are going to browse to the database that you are working on. So this is the database, that's my park access. Click on that. That will point it over to that database. So all the outputs of the analysis will go into that location. Repeat that again, and we should be good with our model as it is right now. Okay, so here I had already put in the Redlands outline and then added the base map to it. So that's nothing that you should be able to do that too. So the next thing we want to do is, first we want to now take away every street. So every street that is not walkable, we'll take it out of the equation. So bring in the rows first, all right, and then we are going to select only the streets that we know people can walk on. So you go into analysis and then you go to extract, and then you're going to say select, bring the select out, and now we want to connect. And then before we proceed, ensure that under customize your extensions, you have to ensure that your spatial analysis is enabled. All right, do that. Connect the rows to this guy here as an input. Go to the select, and then we are going to build an expression to say that we want the row type to be equal to get unique value a minor street, or row type double click equals to the arterial. So we don't want the highway, so we'll select that, do that, and now this first portion of the model should be good because we're giving it what we want. So here, this is what I was saying in class. Let's just run it piece by piece to make sure that it is giving us what we need. Okay, so that is done. So let me take off the street and then add in the new street. And let's take a look and see. A minute. So now you can see I don't have any of the freeways. The freeway streets are not there. Although in your table of content you are seeing the highway is not there. The only reason it's showing it in your table of content is because the layer, that field is a subtype, so automatically to show even though there is no feature, it will still show. So here, if I change the color of the highway to red, you shouldn't see anything red on my map because that layer is not there. So don't worry about seeing it in your table of content. It's because the layer is a subtype. All right, so now that we have that street enabled, what we are going to do is we are going to run what we call a Euclidean distance. Your Euclidean distance is nothing than a buffer around those streets that we've identified as walkable. So it's going to give us the distances out from that street, and then that will tell us that if you are within the closest you are to the street, the more likely you are to walk on that sidewalk and go to the park. So Euclidean distance can be found under spatial analysis tools. Go to distance, and then when you go to distance, you are going to see you have Euclidean distance. Drag that guy, and then the output of your street will be the input for that, and then simply run that. Now once it's done, add the output to your map and take a look at what it's giving you and see if it's what the Euclidean is supposed to look like. So this is how the Euclidean is supposed to look like. The smaller range means the closer you are to the streets, and then it keeps generating those rings. But what we want to do is we want to specify how it does the classification. So the distances from the street, we want to control that. So what we will do is we are now going to go ahead and reclassify this output raster. Okay, so we are going to bring the reclassify to. It's also under spatial analysis. You go to Reclass, drag in the Reclass to, drop it, connect the output of the Euclidean as an input, then double click on the reclass, because we have to go and specify the range that we want. Now as you can see, the reclass here is giving us up to about 9 value. So what you do is hit on reclass button here, and when you come over here, change this to 6, and then change the classification method to manual. Okay, so 6 manual, and then come over here, and then what you're going to say is you want the break to be first 100 feet, the next one is 500 feet, the next one is 1320, the next one is going to be 2640, then the next one is going to be 5280, and then the last one is going to be 25, so 25,000. Okay, so do that and then hit on OK. You see how your bell curve is looking over here. That's good. Then hit on that, hit on OK on that, and then here the numbering. So here we go 1. The new numbering is if you are 100 feet from the street, you are our favorite. If you are 500, you are second, so on and so on. So here, this one is going to be our least, so we'll give the value as 9. So we'll tell the 9 will tell the analysis that this is the least desirable value. So hit on OK on that, and now let's run the reclass. Let's run the reclass 2 as well, and then let's take away the Euclidean and then add the reclass value. And this is how the reclass is now going to show us. So it's giving us, if you look on the example, that looks the right way. So here, if we want to change the symbol of the reclass, we can do that. Alright, so we can go here and say we just want to go pick green, and that gives you that color that you saw in the analysis. So that is the component of the cost. So this is the cost surface. So what we've done is the first part of the analysis, which is the cost surface. Okay, so the second part of the analysis involves us actually now converting the park. So if we say the parks are points, the park data we had are actually points, and therefore we cannot use the point as a way to actually get people to walk into the park. So we need to get parcels that are actually the edges of the parcels of the parks will determine the entry points that people will use to enter the park. So the next set of models we are going to do is to take the parcel data and then extract the parcels that intersect with the park point layer, and then convert those parcels into vertices. We want the corners of those parcels, and then that is what we are going to use to actually calculate our suitability analysis, the park accessibility analysis. So here, the first thing we want to do is we want to bring in this parcel data. So drag in the parcels, okay, and here we are going to use a couple of different tools. So the first tool we want to do is, in order to do a select, just a simple select in the model, we first have to make a layer out of this parcel data before we can use the select by location. So to do that, we are going to use a different tool. We'll go into data management, and then go to layers and table view, and then there's an option that says make a feature layer. Make a feature layer right here. Drag that guy here, okay, connect it. Now that's all that we're doing over here. We're not doing anything again. And then now we can go in and say that select by location. So now under the same tool, there's an option that says select by location. This is the only way you can do select by location in a model builder. Okay, so that in the select by location, what we are going to say is that we want to select To double click on that, we want to select parcels that intersect with the parks, so the Redlands parks. Okay, so we want that to be, say, we want to select parcels that intersect with the parks. So here, if we do that and we run this analysis up to this point, you are going to see that it's going to highlight all the parcels that have all the parcels that intersect with the parks. As you can see, those parcels are selected. Okay, so in Model Builder, for us to just extract those selected parcels, we are going to use the tool called copy. So here, if we use a copy, by default, ArcMap is only going to copy the features which are highlighted. Okay, so we'll go to you go to features under data management, and then say copy features, drag it over here, connect the output of the select by location to the feature, right click on that. Now let's run that. If we run that, when that is done, if we add that and we take out the old one, you're going to see that it's going to add only the parcels that were actually connected. So you can see there's those parcels are the ones now showing up on the map. Okay, so you can see, bring it up a little bit. Those are the parcels, or even take out the parks. You can see those parcels. So we are good. So everything up to this point is good. So now that we have those parcels, what we are going to do is we are going to convert their outlines into points. Okay, we're going to say convert the vertices, the feature vertices to points, and that's what we are looking for. So now we are going to look for a feature called here, and the features is a feature vertices to point. So take that layer, take that tool, drag it in here, and then convert this guy to that, run this guy, and then what we are going to see is that the outputs of those parcels will now have points on them, and that is what we are looking for. Yep, you can see the points are added on that, and that point is what we are looking for in our next piece of the analysis, which is actually measuring the distances that people have to walk to the park. So now we have our cost surface, we have our entry points. So now we can now actually do what we call the cost distance. So to run the cost distance is also located under the spatial analysis. So you go to distance, there's an option that says cost distance. So the cost distance here will come over here. Will actually, it has two inputs. It's taking two inputs. It's taking a raster, the raster input, which in this case is the output of the Reclass here. So here, this is going to be that it's called the Reclass Euclidean D1, this one here, and then my input is going to be what I call the Redlands Parcels copy feature. So that will be your input is going to be your, let's see, no, actually I reverse it. Your input over here is taking the feature, so that will be your Redlands parcel copy, Redlands parcel copy feature 1, this one here, and then your input cost surface will be your Euclidean. So that will be my Reclass Euclidean 1, and I'll keep the output like that, and now connect the two. So that's how you do that, and that'll connect the two. So when we do that, this output here will be the cost, the actual park walk cost. Okay, so we can just run this. Let's run this, and once that is done, we will reclassify that output to the distances that we have, and pretty much our analysis will be done to show how close or how far people are staying from the parks. So allow this guy to do his calculation, and we should be almost good to go. Then the other component is, now that the output of this is going to be a raster. Once we reclassify it, it's still going to be a raster. So we'll convert it from raster to be a feature or a vector, and then we can use that in any other analysis that we are interested in doing. So let's wait for this. It takes a little bit of time for it to do all the calculation, but as you can see, this is the step-by-step. One, we wanted to extract all the rows that we know people cannot walk on to the parks, take those ones out, and then generate what we call the Euclidean distance. So here, let's take a look at, let's turn off some of these layers that we currently don't need, and then add in the new one, and let's take a peek to see how it looks like, at least before we do the reclassify. So when we do that, this is how it looks like. So that's good. It looks like that. So the next thing we are going to do is we are going to reclass this guy. So let's drag in the reclass to reclass is right down under special analysis reclass. Drag this reclass to here. Let's connect this to this, and then go into the reclass again, and then this one too, we are going to specify the distances we like. So go to classify, it will give you this one, and don't worry, say okay to it, and then change this guy to 5, and then go to manual, and then the first one we want is 500. The next distance we are interested in is 1320. The next one we are interested in is 2640. Then the next one is 5280. And then the last one is going to be 100,000. Okay, so we do that. We say okay to that. And then we rank our values. And so 1, 2, 3, 4, 5. That's how we want. So 1, 2, 3. This is going to be our 5th option, not our 4th option. And then the last one will be our 9th, and consistent with the other one. And we will hit on OK on that. And now let's run this reclass. And now let's add the reclass to the map. And let's take a look and see how the map looks like. Let me here we go. So now if we take that one out, you can see that your map is looking like the analysis they had online. So double click on this, and we can simply change the value to use the same colors that they were using. And let's put a little bit of transparency on that, and maybe a little bit more, transparency, about 40, and you can see your analysis looks exactly like what they had online. All right, so the next thing we wanted to do is to convert this output. So if you compare this to that, you can see your analysis is, the rings are the same. All we left is the raster outline, the buffer outline, which is very straightforward, we can do. But also we wanted to convert this raster to be a feature, so we can actually have a feature class that we can actually work with. So to do that, we are going to go and look for a tool under conversion tools. So expand that, and then go from, say, from raster. So go say from raster, you say from raster to polygon. Drag that tool in here. Do a connection. And then, so what it's going to do is it's going to take the output of this and convert it into a raster. And then, but when you convert it into a raster, it's going to be a lot of points because all those rasters are cells. So we'll have to dissolve. So output, add the output to your map and take a look at that. It will be the same, but it will have multiple. If you open the attribute table, you are going to see that you have multiple. See the output table. You have multiple grades. So all the ones, the one that say the grade code 1 are all belongs to the same cell. So what we need to do is to dissolve all of them into one. So here we are going to now use the dissolve tool. So bring this model back again. And then we are going to look for the dissolve tool. So the dissolve tool is under data management, and dissolve is under feature. No, so here let's do a search. Let's do a search real quick. And go to tools, hit on dissolve. All right, dissolve data management. And then here it tells you it's under data management. So if I want to find where the tool is located, I click on that to open it up for me. Come on. There we go. It's under generalization. So drag that guy here, connect the output to that. Okay. And then open it up. We want to dissolve all. So open the dissolve tool up, and we want to dissolve it using the grid ID. And now let's run this guy. The output of this one will be our layer that we are interested in. That it will be our future layer. So what we can do is we can actually symbolize this categories. Use the grid code, add all values, change this stuff from here to that, increase the transparency on this layer, and now your analysis look like the one that was on the. Let's take those ones out. Now your analysis look like exactly what was on the tutorial that we sent earlier on. So the only other thing they did was to do the buffer on the points. So here, if we want to run a 1 mile buffer, we can do that quickly. Let's go to buffer, will be under analysis tools, be under proximity, drag that buffer tool here, and then your input to the buffer is going to be the parks. So my input is going to be my Redlands parks. Here I'm doing a 1 mile, and then I'm going to say dissolve all. There we go. And simply run this. And add this to the outline. And that is our buffer, and we can just change the field to be none. And then the outline, we can give it a blue, increase the width a little bit, and you can see your map look. I use a different the gray base map, but aside that, you have done your park walkability analysis. So if you compare this one to this, we've been able to reproduce the same thing they have the online tutorial with our own. And what it means that the darker green is areas that are, or houses that are very close to the park and they can easily walk. The next ring is the next option. So you go from 150. If you go from, see how they have it, for 500 feet to a quarter mile, half mile, 1 mile, and then everything greater than 1 mile, which will be the classes that we have over here. and that's what you can do in the symbology. And by pretty much you've been able to reproduce the park walkability analysis. So the homework I gave you was to say, now as opposed to using the parks as the park walkability, take the school points. So I gave you the school points in the data. Take the school point and rerun the same analysis, but this time it will be a walkability analysis for schools. So you can reproduce the demo, this demo that we've done, or what we did in class. You can reproduce this, but this time you are only switching the parks to the schools, but the concept will be the same. Okay. Now you have the bike lane and all that. We can combine that as well. So um, we could take the parks, the streets. No, we could take the bike lane, the trails, the streets, and combine them for one surface before we can combine that with the point access and all that. So it's possible we can do that as well. So hope this is useful, and it will help you with what you're supposed to do. So enjoy it.